Today, we're going on a bit of a journey, but not on the road. We're going into it. We're going to peel back the asphalt and uncover this complex, highly engineered world that's hiding right underneath our wheels.
And our guide for this deep dive is this: the Oman Highway Design Standards. Yeah, I know, it looks super technical, right? But trust me, these documents tell a really fascinating story. It's all about precision, geology, and even chemistry. So, let's get into it.
I mean, we've all been there, haven't we? Bumping over a pothole and wondering, what is going on here? You can have two roads, they look basically identical on top, but one is perfectly smooth, and the other is just a complete mess. What's the deal?
Well, the real secret to a road's lifespan, its ability to just take a beating from traffic and weather and time, it's completely invisible to us. It's all about what's underneath. It's all about the foundation.
Okay, so let's start digging, shall we? We're going to break down the anatomy of a modern highway, piece by piece, starting from the very bottom and working our way up.
So pretty much every single road is a system built on these four main layers, and they all have to work together perfectly. It all begins with the subgrade. That's just the plain old dirt you're building on. On top of that, engineers build the subbase, then the base course, and finally, the pavement we drive on. You can think of it like a team where each layer has a very specific job to do, passing the stress down to the layer below it.
Let's look at that first man-made layer. This is really the unsung hero of the whole road system, the subbase. This is where the serious engineering really kicks in.
The subbase has two absolutely critical jobs. First, it's a cushion. It takes the heavy, focused weight of something like a truck tire and spreads that load out over a much wider area. That way, the natural ground underneath doesn't just get squashed. And second, it's a drainage system. It gives water a place to go so it doesn't get trapped and weaken the road from below.
And this is where the mind-boggling level of detail comes in. You see, you can't just use any old gravel you find on the side of the road. No way. The standards say the material has to be hard, it has to be clean, and this is a big one. It has to have very, very little clay in it. And it absolutely cannot contain any gypsum. Why? Because things like gypsum can swell up or even dissolve when they get wet, which would completely obliterate the road's foundation from the inside out.
So, how do they know if it's strong enough? Well, they use this incredible test called the California Bearing Ratio, or CBR. And this perfectly shows you how they think. They literally soak the material in water for 4 straight days to mimic the absolute worst flood conditions imaginable. Then they test its strength. They're not designing for a sunny day. They're always designing for the worst-case scenario.
Actually building this layer is like a carefully choreographed dance. First, the gravel is spread out in really thin, even layers. Then, they add just the perfect amount of water, which helps all the little particles lock together. And finally, massive rollers go back and forth, compacting it until it reaches 100% of its maximum possible density. That means it is literally as solid and as dense as it can possibly get.
All right, let's move up to the next layer. This is the base course. And if the subbase was the cushion, well, this is the road's real skeleton. This is where the primary strength comes from. And right here, you can really see the step up in quality. The subbase is all about support and drainage, but the base course is engineered for pure, brute strength. The material isn't just some nice natural gravel. No, this is high-strength, specially crushed rock. And look at the strength requirement. It jumps from a minimum of 60% CBR for the subbase all the way up to 80% for the base course.
So what makes it so much stronger? The specs give us all the clues. The rock is crushed by machines, which creates these sharp angular edges. In fact, a whopping 90% of the particles have to have at least one of these fractured faces. Why? Because all those sharp edges interlock, like a giant heavy-duty puzzle, creating a much more stable layer. And the rules get even tighter for things like plasticity, which is basically how much the material can bend before it breaks and how much it's allowed to swell up with water.
And all of that meticulous work leads to this number, 80%. That is the minimum strength the base course has to have. It's the structural heart of the road, the thing that distributes all that weight and provides that perfectly rigid platform for the smooth pavement we get to drive on.
But what if you need something even tougher, for highways with just an insane amount of traffic, or for roads in really harsh climates? Well, it turns out engineers can actually upgrade the base course itself.
They do it through a process called stabilization, and it's kind of like following a recipe for a super base. You can mix in some cement to create an incredibly stiff, almost concrete-like foundation. Or you could add bitumen, the black tar-like stuff in asphalt, to get a base that's both strong and flexible and super water resistant. Or if you're stuck dealing with difficult clay soils, you can mix in lime, which actually causes a chemical reaction that makes the soil stronger.
The whole point of stabilization is pretty simple. Create a foundation that is, for all intents and purposes, indestructible. It's about customizing the road's core so it can handle pretty much any challenge you can throw at it, whether that's from traffic or the environment.
So we've seen how you build an incredible road from scratch. But what if the best material for a new road is the old road itself? This last part looks at an innovation that's not just about strength, but also about sustainability.
Turns out you can absolutely build new roads out of old ones. But this isn't just about dumping some old rubble in a hole and calling it a day. Oh no, the engineering standards are just as strict. The recycled materials have to be crushed, cleaned, and carefully sorted. They have to be totally free of junk like plastic or wood or steel, and when they pass the tests, they're often approved for use as a brand new sub-base, typically on roads that don't see as much heavy traffic.
And here's why this is such a big deal. You don't have to take my word for it. The design document says it right here. The biggest environmental win isn't just about keeping old concrete out of a landfill. It's about cutting down the number of huge trucks that have to haul brand new rock from quarries that might be hundreds of miles away. That saves an incredible amount of fuel and slashes emissions.
So the next time you're driving down the highway, just think for a second about that massive hidden structure working away beneath you. That whole carefully designed system of layers. It just goes to show that by really understanding the fundamentals, we can build things that are not only stronger, but smarter too. And it kind of leaves us with a final thought, right? If we can engineer our past into the very foundations of our future, what other amazing possibilities are just waiting to be built?